Hello everyone and welcome to another LeetCode tutorial video. In this video we're going to be going over LeetCode 2712, minimum cost to make all characters equal. So we're going to be breaking down the question, then we're going to be going over it on a whiteboard, kind of explaining how we're going to do the solution, and then we're going to write some code. So before we get into that, let me just say, if you're serious about data structures and algorithms, you want to get good, you want to get better, you want to land that dream job, then I would highly recommend checking out my course. It has a bunch of content all created by me, an ex-Amazon software engineer. I've done it before. I'm going to show you how to do it. We have a bunch of practice questions on there, curated practice questions to help you get better, so you're not just doing mindless practice. So if you're interested in that, it's going to be top link in the description. But let's get into this. So basically, let's break down the question first. Let's read it. You were given a zero-indexed binary string S of length n on which you can apply two types of operations. So essentially, we have a string which is ones and zeros. Cool, that's sorted. And then the two operations are choose an index I and invert all characters from index 0 to index I, both inclusive, with a cost of I plus 1. So if you think about that, 0 to I, and with a cost of I plus 1, what that essentially means is, so first of all, inverting the characters. So if it's a 0, it's going to a 1. If it's 1, it's going to a 0. So we're just going to flip all the characters in this section that we've selected. And then it's also important to note that the cost isn't anything special. It's just the amount of characters that we're inverting. So if we select an index of 2, so we're going to be inverting the character at index 0, index 1, and index 2. The cost is going to be 2 plus 1, which is 3, because we've inverted 3 characters. And so the same applies to the second operation, which is essentially the same thing, but this one was going from index 0 to index I. This one's going from index I to index n minus 1, so the final character. So basically, the first half, or like the first part of the string versus the second part of the string, right? And again, cost is calculated the same way. It's just the number of characters we're inverting. And so we need to return the minimum cost to make all of the characters of the string equal. So we just want to make all the characters either zeros or ones, right? So let's take a quick look at some examples before we get into the whiteboard. So we have a string s equals 0, 0, 1, 1, and the minimum cost is 2. So what they've done here is that they've applied this second operation, so a second operation from here, and they're inverting these two characters, which is going to give us 0, 0, 0, 0. Alternatively, you can invert the first two, which would give us all ones. Either way, same thing, an output of 2. For the second example, I'm not going to go through this right now. We're going to go through this in the future because it'll probably be confusing if I go through it right now. So let's actually take a look at some examples on the whiteboard, right? So just to kind of grasp the basics, we have an example here, 1 and 0. We can either, it's pretty obvious here, we can either get all ones by inverting this one here, or we can get all zeros by inverting this one here, okay? So, and then when we think about the cost, obviously it's the number of bits we're inverting. So if we invert this and turn it into this, right? We've inverted everything here. That's just one character, so that's a cost of 1. Alternatively, if we choose to invert them both, invert the other way and make this one a 1, then that is going to also be a cost of 1. So either way, it's fine, but that's how we would approach that one. Really basic example, just to kind of get your head around it. Let's take a look at this example now. So if we go through it, just kind of think in a more kind of how you do this manually as a human in an intuitive way, right? We obviously have these kind of ends here, so we're gonna either want to change this one here to a 1, or we're gonna want to change this one here to a 1. I think that's like pretty much the first intuitive thing, and both of them are going to flip one character, so they're both going to be a cost of 1. So either way, it doesn't really matter. Let's just flip this one for the sake of the example. And then so now we have 1, 1, 0. So we need to make them all the same. So we need to make them all zeros or all ones. So in this scenario, there's two operations we can do. We can flip all of these characters and make them zeros, or we can flip this character and make it a 1. Now this has a cost of 2, and this has a cost of 1. So in this scenario, this one's cheaper. So what we're going to do is we're going to flip this. So we're going to flip this and we're going to make this a 1. So in this scenario, we only have to flip this bit and this bit. So it's actually a minimum cost of 2 overall. Cool. So those are some basic examples, but now the question is kind of how do we write code? Like how can we do this in a programmatic manner? Because what we've done so far is kind of, as humans, we can intuitively understand what we need to change, but we need to kind of think about how we're going to write the code for this, right? So let's go through that same example, but let's do it in a more programmatic way. So, you know, let's think, pretend we're like a for loop. So we're just going to go from left to right. We're going to go through each of them, and we're going to try and make the best decision with the information that we have. And so our goal is to make all of them equal. So logically, anytime we come across, you know, we're going from left to right, anytime we come across two that are not equal, that's a sign that we need to do some sort of action, because we need to make all of them equal. So if we start here, we start at the first character, we're comparing it, you know, this one's always fine because we haven't seen any characters yet. This one's always okay, this one's always gets a tick from us because we haven't seen any other characters. So technically everything we've seen so far has been the same, so no actions need to take place, okay? So these are equal, this is perfect. Now, cool, we've gone over here, and we need to compare it to our previous one. So obviously, these are not equal. 0 does not equal 1, so that means that some action needs to be taken. So if you remember the rules, the operations we can take, we can either flip this here and make it a 1, or we can flip this here to make this a 0, because we want to make these equal. Now, when we're doing the calculations, this is 1, this is 2. In this case, we want to do this one because it's much cheaper. So let's do this, and sweet. Now we have 1 equals 1. Cool, so everything on this side is now fully equal, which is exactly what we want. So this gets a tick, and now we're over here. Okay, so these are not equal. So again, we need to do something. So again, kind of same logic. We can either flip all of these and make these zeros. And you know, because we've gone through, these are all the same. Anytime we flip them, they just continue to remain the same. So by making this equal to this, it inherently makes this equal to all of these, anything that's over here. So we can either flip these, or we can flip these, which is just 1. And again, 2 or 1, this is a cost of 1, which is cheaper. So we're going to flip this one. And so we only had to flip this one, this one here and this one here. So that was a cost of 1. This was a cost of 1. So total cost is 2. Sweet. So same result. And now we've done it in a programmatic way that's going to be really easy. Let's do one final example with the a given example that LeetCode gave us, just so we kind of understand it on a bit more of a larger scale. So again, left to right, this one's always fine, so let's not even bother checking it. Let's go here. These are not equal, so we can either change all of these, or we can change this. Pretty obvious that we would just want to change this one here. So this is going to be now 1, because this is a cost of 1, this is a cost of 5. So we only did a cost of 1, so I'll just keep a running total over here. So 1, and then, cool. Now let's go over here. These are not equal again. So we have a cost of 2 here, or we have a cost of 4 here. Let's do the 2. Let's just switch all of these to a 0. So 0, 0. Cool. So now we have 0, 0, 0, 1, 0, 1. And that was only a cost of 2. Sweet. So now we are up to here. And so in this scenario, I can either flip all of these, because again, not equal, or we can flip all of these. Either way, it's the same thing. They're both 3, so we'll just add a 3. We can choose to do whatever we want. I will make all of these 1s just because I think it's easier to kind of get your head around. 2, 3, cool. So now we have 4 1s. Again, go to the next one. Not equal, of course. Now we are past halfway, so this is now going to be 4 versus 2. So anytime we need to change them, flip some bits, it's always going to make sense to do it on the right side from now on. So there's 2. Let's add 2 here. So we need to flip both of these. So I'm going to change 1 and 0. Okay, finally, last one, we have a 0 here. And so obviously we can flip this, we can flip all of these. In this case, it makes much more sense to just flip this to a 1. And that was a 1 cost operation. So this here only costs 9, so 3, 3, 3. So the total cost of 9, that's the minimum cost. So that's kind of a look at how we're going to do it. And from that, you can probably understand how we're going to write the code. But let's get into actually writing that code. So we'll initialize the running total of the cost to 0. And then to make our code more logical, let's get n, which is just the length of the string. So now we're going to create that for loop that I talked about. So for I in range 1 to n. So this is going to go through each of them, and we're skipping. Notice that we are skipping the first element because it's always okay. And then if the current one that we're looking at, the current element, the current bit, does not equal the previous one, then in that case, we need to do a flip of some sort. So we can either flip all the ones to the left, which is just going to be I, or we can flip all the ones to the right, which is just going to be n minus 1. And that's actually it. We can just return the cost now. And that is all the code we need. Really basic solution. Let's just make sure this runs fine. Sorry guys, made a typo here. N minus I, it should have been, not n minus 1. Sorry about that. So if I submit it now, this should all run perfectly. And as you can see, very efficient and doesn't use up much space. So just O of 1 space, constant space, we don't need any extra space, and O of n time complexity. So I hope that video was helpful. I hope that tutorial was helpful to you. Thank you guys so much for watching. If you did like it, please make sure to like and subscribe. Have a good one.